Hello. This is Postgres FM. I'm Nikolay, Postgres AI, and my co-host is Michael, PG Mustard. Hi, Michael.
Hello, Nikolay.
And guess what we are going to discuss today?
Oh, guess. Is it append-only tables?
Exactly.
Oh, I got it right.
I was surprised to hear we haven't discussed it in the past. I'm sure we touched it many times, right?
Yeah, for sure it's come up in episodes, but me too. When I saw it in our listener suggested topics, I did have a few searches on our site just to make sure we hadn't talked about it already as a whole episode, and yeah, agreed. But it's not something I see all the time. Like it's relatively common, like to have an events table, but even then, I mostly see append mostly tables rather than like append.
We need to distinguish. Yeah, I was thinking we are going to discuss both. Actually.
Yeah.
Do you feel we need an episode for append mostly tables? No.
I don't. Well, I don't think this is super complex. I think it's quite nice because almost by definition, if we do accept that it's append only, we've got quite a narrow scope and there's only a few things to consider. Maybe it gets a bit more complicated with append mostly, but yeah, we can definitely cover that today. I think it's still not that complicated.
Yeah. Where do we start? Like definition?
Go for it, yeah. Why not?
Well, if we just insert, that's append only. That's it.
Insert and select, I would say, yeah. No updates, no deletes.
Select is allowed, right. Yeah, insert and select. This is the only two things we can allow ourselves from DML, data manipulation language. And that's it. Yeah, we just select and insert. This is append only. If we have occasional deletes and updates, it's append mostly or insert mostly. I don't know how to say.
Yeah, I like that.
And why do we care about this particular use case? Because it has characteristics, right? It usually has, if it's append only, for example, we don't care about dead tuples anymore. No bloat, right? It's good. And usually we talk about huge volumes of data. And at some point we think, we need to compress it, we need to offload it maybe to cheaper storage or just clean up because this old data is not needed anymore. In raw form, sometimes it's aggregated and in raw form we can just remove it from database. Or we just, need bottomless. And usually we want inserts to happen very fast because a lot of volume is huge, so we need to make sure performance of inserts is good. Did I miss anything?
No, I think those things aren't necessarily always true for append-only tables, but they correlate. Like a lot of the use cases for very, very fast-growing data, and by definition, append-only means it's never going to decrease in size. It's only going to keep getting larger
unless
and larger
you clean
and larger.
Unless you clean. There are specific cases. For example, imagine we discussed many times the topic of slow count, and if you can allow like a synchronous calculation of count, maybe it's like materialized view or something, I don't know. So idea is instead of updating the count somewhere on each insert in the original table, you can aggregate operations in intermediate table, and then it's append only. So you register events in some table, and then you process chunk and reflect this in count in final storage, and then you can delete it or better drop this partition or truncate or something. Right. Yeah. In this case, it's append only, but it grows, and then the size drops. It happens also, right?
Yeah, I think dropping partitions definitely pushes the definition of append only, but it's the thing that makes sense to do in most or a lot of cases at huge scale.
Mm-hmm.
But yeah, it's still append only if we're dropping partitions.
Yes, this is how we should do it.
No, I know, but do you see what I mean? You mentioned deleting data, But by
Well,
we're talking
again, it's append only. We drop partition. We never delete. We never update. It's append only. But if we don't need like last year data, we already processed it somehow, made all calculations we need. We can get rid of raw data. We just dropping partition. It's the best we can do instead of cleaning up somehow using delete. So I think we need to discuss it because I did it many times and participated in huge projects in very large companies. The idea, let's offload all archive data. It was e-commerce. Old orders, let's offload it to cheaper storage for longer term storage. And then we need to delete it in original place, original database. And it was not partitioned. Deletes, it was a project for a couple of months,
Yeah.
Because it was like downtime is not acceptable. It costs a lot of dollars. E-commerce guys know for very, very well. They can calculate it each second of downtime, how much it costs to company. So if I had partition table there, it would be magic. And it's append only. Like no, that particular table was not append only, right? But it can happen with append only. If we, for example, we have audit log, all like some actions are stored in sub append only table, but we have a policy to store only 2 years worth of data.
Yeah.
Then I would prefer to drop partition with all data. That's it. So cleaning up is a very important topic for append only tables. This is what I was trying to say.
Yeah, I completely agree. I think there are other benefits to partitioning with append only or append mostly as well. Due to like if we do have the occasional update or delete, by having partitions,
that's bad.
Yeah, well,
That's bad.
partitioning helps with that as well, right? So let's zoom back out. Maybe we've got inserts and selects. So we might have to, if we're talking about a very, very high volume, we might have to worry about insert performance and select performance.
We can also have, sorry for interrupting, we can also have copy.
Yeah, sure.
In both ways, right?
And I guess that's about to come up if we're talking about
also common table,
optimizing.
like table, which reads everything. Yeah, but it's kind of select. So inserts or selects, no updates, deletes, and so on. Yeah. So what use cases? You wanted to discuss use cases, right?
Or even I was actually thinking of diving straight to performance of I think there's a few things that we don't have to worry about, and a few things that we can then optimize for. Like if we're having to insert extremely high volumes, which sometimes these use cases do lend themselves towards, if we're, I think IoT, for example, Internet of Things, if sensors are sending information and we're logging for each second amongst thousands or tens of thousands of sensors, that can end up being a lot of data. So inserting can be a bottleneck, and you might make design decisions for those tables that you wouldn't make if you had a different type of table or a different type of data. So there's that side of things, but then there's also the read side of things, I think, and I think those things maybe sometimes play off against each other. So with the fact we've got append only, we have some benefits to, like, index only scans, for example, become even better. I know you often talk about always trying to get index only scans, but in a table where the data is often changing, that can be a losing battle. It can be a battle that's not always worth fighting, or it's maybe not always worth including as many columns to the index, for example. Like there's different trade-offs for append only versus
let's unwrap everything here. You mentioned so many things in just a minute, right? So first, let's talk about performance of inserts. I would say ideal situation is we don't have indexes and we don't have triggers, including foreign key triggers, because foreign key in Postgres internally implemented via system trigger, and this trigger is going to slow down inserts, especially if you have if you need to insert a lot of rows. If you just have a few foreign keys, it can multiply the duration of this massive insert. So ideally we should get rid of foreign keys and keep as few indexes as possible for this particular case. I remember in some cases I decided to go without primary keys, breaking a relational model and so on. Like, there's no relational model in Postgres in any relational database which implements SQL model, data model, which has null, and it breaks relational model completely anyway. But this is a different topic. Side note. Anyway, so it's not good to be without primary keys, but sometimes you think, I just need to dump this to some table reliably. So we have ACID, so Postgres guarantees it's stored, it's saved, it's replicated, it's backed up. But even one index, sometimes you think, it slows me down, right? And I remember I decided to leave without primary key, and it was a weird case, but it was just some archive, maybe it's just for audit purposes. And I decided to use Brin at that time. Brin is actually a good idea to consider if we have append-only, because layout physically, rows don't move. If we have a row, it's a tuple, it's saved in some block, it's there, right? So this is exactly when Brin indexes work well. And we had an episode, one of our first episodes, I remember.
It was
Brin indexes. Brin, it's a block range index, right?
Yep.
Yeah, so it's very lightweight. It speeds up select performance, not as good as other indexes, especially B3, but it's still good, right? Or we might consider hash indexes also, right? Because they might be more lightweight than B3 sometimes.
Well,
they're smaller,
I think,
for example, right?
Yeah, but when it comes to append-only, I think you make a really good point. Each index we have slows down the inserts. So the fewer the better, possibly none if we aren't, let's say it's a table we're never reading from, or it's an audit log that we only ever have to read from extremely rarely, we might consider 1 or even 0 indexes on that. Maybe not an audit log, because maybe that's not one you would actually be writing an insane volume to. But I read a timescale. So timescale, they have to worry about this kind of thing. They've designed for these kind of time series workloads. They've written a good blog post on optimizing inserts, and they list all the same things as you and go further. So they, as well as foreign key constraints, basically other constraints can add overhead as well. So for example,
of course,
a unique constraint. Yeah, check constraint, but unique constraint.
Well, index additional check, for sure.
Yeah, so not having it, basically deciding for each constraint if you really need it or what value it's adding, having it makes sense.
That being said, I must say, like in most cases, I prefer having primary key, because it's like the center of consistency, of data consistency, right? So it's good to have. But it depends, right? It's good that you mentioned timescale, but I think, we will return to timescale. My question to you, tricky question, but I think you already know, and I must admit, when 2 years ago we started podcast, I didn't realize it fully. Now I realize it much better. So we have an index. What operations does it slow down? You said it slows down inserts. This is for sure. Does it slow down updates? Well, yes, right? And there's a mechanism, hot update, which like deals with it in limited number of cases. Does it slow down delete? Well, maybe no, because during delete, index is not updated, right? Postgres only updates Xmax, as we discussed already a couple of times. Does it slow down selects? What do you think?
So we've talked about how having a lot of them can.
Yeah. It slows down the selects, especially if we have a lot of them and high frequency of selects, and this is about planning time. And log manager logs during planning, all indexes are locked. It's some overhead in very heavily loaded systems to keep in mind. But in general, so I would minimize number of indexes and try to not to use foreign keys. Foreign keys, in many cases we can imagine they exist have maybe routine checks that referential integrity is fine, right? But drop them intentionally because in this case we want, for example, good insert performance. And as usual, I would like to remind that when I say all this, in many cases when I deal with new system, I have some like these principles, but I never trust myself. I always check again. Checking should be like considered, like sometimes you spend time there, right? But it's worth doing experiments.
Yeah, and I would say we're talking about extremely high volumes here. If you can, I would much rather normally have primary key, have some foreign keys if they make sense, and have a unique key if I need it, and then test if like, can I get better disks if I need to? Like, are there other ways I can improve? Like, I can cope with higher write performance instead of
perform checkpoint tuning if you expect huge volumes that need to be stored.
Yeah, so maybe pay for it in other ways. Is only at
have
the
more
absolute...
memory, bigger buffer pool.
Exactly.
Make sure backends don't write all the time. It like depends, right? So checkpointer is not crazy, it's not too frequent, and so on. And there's a lot of stuff here, and if we think about selects now, what's the number one problem usually? I think like it makes me so like I'm still wondering how come we lived so many years until I think Postgres 12 or when auto vacuum insert scale factor was added. I think Dorothea initiated it. Dorothea.
Version 13. I looked it up. Yeah, version 13.
Okay, it's very recently compared to like my experience with Postgres. So strange. What it adds? Originally, Postgres vacuum, which also maintains Postgres statistics, which is important for good query performance, including selects, right? Originally, it was triggered only after, say, like 10% by default, 10 or 20% of rows are changed. There is some complex formula, not very complex, but some formula, but roughly after 10 or 20% of rows changed, change means deleted or updated. It triggers, but not after inserts. And only in Postgres 13, specific parameter was added. I think by default it's also 20% or 10, which tells AutoVacuum to run and process a table after 10 or 20% of rows were added.
Yeah, and I looked this up, and it's because there's three jobs, right, of AutoVacuum. There's the removing that there's roughly removing dead tuples.
4 jobs actually.
Freezing and analyze statistics.
Removing the tuples, maintaining visibility maps.
Maintaining visibility maps, of course, yeah.
4 goals, yeah.
4
Maybe
goals.
actually more, but these 4 come to mind quickly.
Yeah, and if you're only doing inserts, you don't need the removing dead tuples job.
Yeah.
But that isn't the only thing Vacuum's doing. So this then enables the visibility map and the freezing to happen.
Well, freezing will happen regardless of inserts. It will happen. Well, we can insert to different table.
Yeah. Okay. Yeah. Good point.
And AutoVacuum will see that xmin or xmax or both xmin, right? It's very. In the past, we have risk of wraparound, so it's time to freeze this table. Yeah. We can have 0 operations in terms like table can be left unchanged for many, but at some point AutoVacuum decide, okay, it's time to freeze.
But you're right, the visibility map would never be like that.
Visibility map is huge. You mentioned index-only scans, the performance of aggregates, counts, right? So we do want to keep it up to date. I think default is not enough as usual with AutoVacuum. We must tune it, and even cloud providers, their defaults are not enough. We must tune it and go down to 1% or smaller, and make sure AutoVacuum maintains statistics and visibility maps more often. So performance of selects, including index-only scans, are good, right? Performances are good.
Another reason to partition as well, so you can keep those.
Yeah,
that makes sense. I was going to say it's 20%. So it is quite high still, as you say. Would you ever switch to...
Insane. I cannot imagine any OLTP system, any website, any mobile app, which would be okay with Postgres auto vacuum defaults. This, like, that's it. Like, I don't know why they are so. They are so for what? We have so many beautiful websites working, huge systems working with Postgres. It's so cool to see that Postgres handles so big workloads, but these defaults.
Well, and the strange thing is, this one, for example, if you did reduce it to 1%, it would add overhead on small systems. Sure, if you've only got 100 rows, it runs vacuum every row for a while, but who's running a small system that can't handle a vacuum of 100 row table every row? Like, that's fine.
And also,
like that.
With append-only specifically, when some page is already processed, it's marked all visible, all frozen, or whatever, vacuum just skips it.
Yeah, so it wouldn't even be much overhead.
There were many optimizations in this area, so to not do work which can be skipped. So it's doing good job skipping, and it's many years already. So I think I never saw any system, and I saw maybe already 100 of them, different sizes, websites, like OLTP, right? I didn't see any time we decide, oh, you know what, we need to increase scale factor. I don't remember this at all. We can throttle it if we can balance work among many workers and so on, but deciding let's make work of auto vacuum less frequent, 0 cases I had. Yeah. Maybe my experience is not enough. Maybe one day I will see such a system.
I've not seen one either.
Enough rage about defaults, my usual fun I have with Postgres. Let's talk about partitioning maybe, right? Why do we want it?
Yeah.
I see several ideas here, and timescale DB is definitely for append-only tables is a good thing to have in many senses. But unfortunately it's not available on managed offering except their own timescale cloud, right? And some others, but some others usually choose Apache 2.0 version, which doesn't have compression, right? So
it doesn't have a lot of their good features, yeah.
Yeah, so partitioning is good. Again, there's some rule, empirical rule. We say, like many people say, not only I. Let's consider partitioning if table exceeds 100 gigabytes or has chances to exceed 100 gigabytes. Partitioning adds complexity. It's not as well automated as in Oracle, but it's a very important tool to consider, and many factors here. First, for example, you might say, okay, I have partition where I insert, and then many partitions where it's like my archive. And as we decided, like we want very low number of indexes in the main partition, which is receiving inserts, and constraints like foreign keys and so on. But there's no such problem in all archive partitions, right? We might have more indexes there and constraints and so on. This is one thing. Second thing, auto vacuum. If occasional deletes or updates are happening, the block which contains the row, that tuple basically, right? It's out of visibility. Like it's marked not all visible anymore and not all frozen anymore. So vacuum needs to process it, and it's good to have data locality. So archive data is in some partitions, and fresh data is in particular partitions. So auto vacuum is focusing on fresh data in fresh partitions. It reduces the number of blocks it needs to deal with, right? Because all data is rarely touched, so auto vacuum visits it very rarely, right? This is another reason. Cleanup is another reason as well, right?
I think cleanup's the biggest reason. I think
maybe, yeah.
I think maintenance, partitioning helps so much with maintenance. It does have other benefits for sure, but it helps so much with maintenance that I can't help but feel like that's the biggest one. And I actually have started to say, I think I must have stolen this from somebody else because it's too clever for me, but partitioning based on how you want to eventually delete data makes sense. So if you want to eventually delete old data, partitioning based on time makes sense. But for example, if you're a bit like B2B SaaS and you eventually want to delete data based on a customer quitting the service, you probably want to partition based on
or both the level of partitioning also.
Yeah, exactly. But that being the like a guiding principle for how you partition, because it makes that deletion or dropping so easy.
What will you do with data, right? And as I said, I participated in projects where delete was a big issue, and of course with partitioning it's very different and it's good.
Yeah,
deletes can be problem. In Postgres, deletes, like if you have a terabyte, 10 terabyte table and you need to delete 20% of it, it's a big headache because you need to make sure vacuum will be okay. Auto vacuum will catch up all the time. You need to pay attention to checkpointer, and you need to find a way how to delete so delete doesn't degrade. This was my problem. So I created beautiful queries, but they degraded over time because of that tuple accumulation and bloat accumulation as well. So I needed to adjust them and so on. So there are many problems with delete, and it takes time to delete millions of rows. If you rush with it, you can put system down or have degradation of performance. Not good.
And it can really affect even your select performances. So you mentioned Brin is probably the one where it used to at least get affected the most with the default way of creating a Brin index. If you have a row inserted way back in an old, like if you don't have partitioning, if it goes miles away and you get some real scattered data, Brin performance can end up effectively looking like sequential scans. So
and all indexes degrade. B3 degrades very quickly if you perform deletes and updates, and you need to rebuild it. And rebuilding is better with partitioning because the smaller partitions are, the faster rebuilding is, and X-min horizon is not frozen, right? So auto vacuum is not affected in whole database, right?
Yeah.
So it's better. Yeah. Building and rebuilding indexes, vacuum itself, maintenance tasks are good if you have smaller physical tables. So partitioning is great, right?
Yes. On the Brin thing, I'll link up the old episode we did, but the min-max multi, I think, makes a big difference, especially if you don't have it handles loads of outliers, so I do think that's easier. And if you are able to keep on top of auto vacuum, I guess the B-tree stuff doesn't degrade that quickly. So I feel like these things aren't as big a problems anymore. But yeah, often in these cases, if you're dealing with high volume, like many thousands of queries per sec, like just extreme volume, anything you can do to help fight on the performance front will be helpful.
Yeah, and as usual, when we touch partitioning, the state of caches and buffer pool, for example, if you have archive data which touched rarely, those blocks are evicted from the buffer pool, and cache efficiency might grow. Hit read ratio might be better. But yeah, I agree with you. So partitioning is good in many senses. It comes with price of overhead and maintenance as well, but it's worth to have it. But imagine, like all this said, we moved slightly from append-only to append-mostly, right?
Yeah.
But let's move back to append-only. Imagine we have many partitions where data is not changed, archive, indexes created, all frozen, all visible. It's a beautiful state of data, right? So all index-only scans are working well, and that's it. Maintenance not needed, auto vacuum not needed there, and so on. However, what if we have 100 terabytes of data, and this is like heavily loaded cluster, we have many replicas. The data is not changed as good. It's evicted from buffer pool, but we still need to keep it on the main storage, right? And at some point we think, we pay a big price because this data is replicated. It increases the volume of backups, full backups if we consider, right? So this is this legacy, it's a lot. And if we have, for example, 5 replicas, 1 primary, we need 6 times to store the same data, and nobody is reading. Like, people read it occasionally. It's,
sure.
At some point you think it's not efficient, and you think I would rather to store it somewhere else, not on the main disks, not on SSD, fast SSDs, or I don't know, NVMe's I have, or cloud storage, which is also expensive, right? So this leads to two ideas. First idea is it would be good to compress it, right? Again, TimescaleDB, full version of TimescaleDB is doing a great job, and their blog posts about compression are great. I like especially one, I remember, first big one, which explained algorithms, like in row and like basically kind of column compression, although we still have raw storage, is great. And also, I think second topic here, which opens up naturally, is what I know Aurora now offers it, right? And Neon and Timescale as well, like in cloud only. Bottomless approach, when old partitions are offloaded to S3 or object storage, JCS on Google Cloud, or blob storage on Azure, how it's called, I don't remember. And now even Hetzner has it. They just recently released, which is big news. I like it because I like their prices, and I worked with them since I think 2006 or so in a few companies. When you bootstrap and you have a small startup, Hetzner is like number one in terms of budgets and the hardware they can offer. So they just recently released S3 compatible object storage, right? So we can have normal backups and so on. But what to do with old partitions? It's natural way of thinking. We don't want to keep them on these expensive disks we have, having multiple copies of that. So offloading it somehow, like implicitly, like transparently in background to S3 or S3 compatible Mini or something, if you have self-managed Postgres, it would be great, right? And so we have it in Timescale Cloud. I think Neon also does it, right?
I don't know.
Bottomless. Like Neon, they store data on S3 originally anyway. So idea is we want to have petabyte size cluster, but don't pay for lots of disks and headache it comes with. And for Append-only, it's very natural to decide, okay, we want to store data forever, not to clean up, but we want to have it, we want cheap storage here. So S3 is a good idea to consider, and it has tiers also, right? So it can be slow to retrieve, but it's okay because it's rare, right?
Well, and it depends what you mean by slow. Like, I think there can be performance advantages. I think when some of this data is fresh, we might want to retrieve it row by row. Like if you're looking at some audit logs, you might want to look at some recent ones that you might want all the information about them. But if you're looking at data from 2 years ago, there's probably a higher chance that you're looking at it in aggregate. On average, how many audits of this type were we having in 2022 versus 2023? And I think actually the types of queries that happen on older data tend to be these aggregate ones that often perform better once it's column store compressed. These file formats often suit that kind of query. So I don't even think I know what you mean.
Lacks compression, good compression. It lacks it. Yeah. And TimescaleDB compression, I have seen how good it is. It can be like 20 times smaller, and indeed, like if they even support data changes for compressed data, which is great, right?
I have seen a project or two come about lately. I think open sourcing some of this stuff, or at least putting it under the Postgres license. Is it PG Parquet that allows you to?
Yeah, but it's different. It's for analytics, and actually for analytics, we also might want to consider append-only tables, obviously. But there is a new wave of this, and many companies look at it. DuckDB, not PGDuckDB.
Yeah, DuckDB.
Right, and the idea, let's marry it with Postgres, and there are a few projects. I looked at a few ones recently, and one of them was just released maybe last week. And I remember they use logical copy from original data tables, regular tables, to these tables which are stored on I think in Parquet format and on object storage, and then DuckDB is used as processing for analytics. But I remember, I think Alvaro commented on Twitter that I'm not going to consider it until it works with like basically CDC, logical replication or something, because right now it's only full refresh of, like, it's not serious, but they will do it, I think. Also, I think Neon guys looked at DuckDB and I saw some activities, and Hydra, right? They also looked at DuckDB.
But I understand that most of the marketing at the moment is around analytics use cases, but I don't see why it couldn't work for append-only.
Data types might be issue. I looked at a couple of extensions because I have a couple of customers with such need to offload all data. And Parquet this format supports only like mapping of data types might be tricky if you have some complex data types, as I remember. And when I looked at some extensions, it didn't work well. And I think right now, I have in plans to look at Tembo's extension, which is called PG tier, for tiered storage, right? And the idea is with this extension, we can have all partitions on object storage. It's a great idea. So if it works, it's great. I just haven't looked at it yet. If somebody from Tembo is watching, listening to us, please let us know if how this project works already. Is it already production or beta stage? I'm very curious. And is it worth trying? And what are the limitations, for example? Maybe we should actually have a separate episode, because I think this extension might bring bottomless idea to the Postgres ecosystem for everyone, right? It's great. It's open source, unlike what other companies do. So kudos to Tembo for making this open source extension.
And is it transparent? Do I have to? Because I think some of the DuckDB stuff, I would have to be.
Yeah,
I'm not sure if I have to write.
I don't know. I don't know. It might be semi-transparent if for example, if you need to make some transitions with old partitions. I'm okay with that, and I can even create new partitions in background and move all the data from one old partition to this kind of new old partition, which already has different storage. This is doable, so it's not a big deal for as I see it, right? I think what, for example, Timescale Cloud has, it's transparent, and they have some kind of interesting, as I remember, very in rough form. They have something also with Planner, and some algorithms to decide when to bring this data to caches and so on, right? So it's interesting. But idea is we want partitioning to evict blocks with all data from memory. One thing, but then we think we want to evict them from our disks, because disks are also expensive, right? Let's evict it. And this is alternative idea to cleanup and to compression, or compression goes well with offloading as well. I don't know. So Parquet format is definitely good with compressing data in terms of column storage, right? So if it's time series, it's good. So there are interesting new directions of development of Postgres ecosystem here. And I think we mentioned few projects, both commercial and open source, which is great. So if someone wants to store petabyte of data, is preparing for it, doesn't want to delete everything, I think there are ideas to consider. Well, we didn't mention with partitioning, you can also have some kind of foreign data wrapper and store it on very cheap also Postgres class. It can be Postgres, it can be not Postgres as well, right? But for example, we can consider a cheap Postgres cluster with very slow disks, HDD, for good price, and we can have foreign data wrappers and offload it from main cluster to that cluster and live with it. There will be some corner cases maybe with transactions failing sometimes because of, I don't know, because of I expected foreign data wrappers, Postgres FDW code in terms of how it works with, basically you need 2PC, right? You need two-phase commit to have a reliable commit because it's distributed system already. But without OPC, there are risks to have inconsistency, for example. And
but not if it's append only, you're never going to change that data once by the time you're pushing it to a different server.
Right. I remember I inspected code and found some kind of edge cases, maybe like even corner cases, but for inserts it's also possible. You wrote to one place, you're trying to write to another place. This one is already committed, here it's not committed. But I remember code was quite smart to reduce the probability of some cases, but it's not 100%. As I remember, it was like 5 years ago. So I haven't revisited it since.
Tell me if I'm wrong, but you're saying new partitions would be on the local Postgres, and it would be old ones that we would move to the second.
Yeah, if we don't have inserting transactions which deal with multiple partitions, there is no problem at all. Yeah, and the old we can move to with Postgres FDW to different cluster. So you're right. No inserts happening, no problem.
Cool.
Select only.
I never considered using FDW for partitioning. For old partitions.
It's natural. Yeah. It's natural. This is how many folks were going to have clustered Postgres, right? I mean, or sharding.
Kind of sharded, yeah.
Sharding, yeah. But this path has issues. Yeah, it's a different story.
Here be dragons, is it? Or what's that old phrase?
And I don't know. So, okay, we discussed many things.
Yeah.
I feel we might be missing something, right? But for good overview, I think it's enough for general overview, what's happening with append-only tables. And so I think it's interesting topic actually. And
I think so.
Many people need it. Many companies store logs and so on in Postgres. And I'm looking forward to the future where Postgres at some point will have better compression and bottomless feature. And as I like to say, imagine timescale DB was Postgres license. Okay, this is, I think, should happen at some point. I know there are people who don't like this idea, but they developed so good stuff that Postgres would benefit from it. I know some people would not be happy with these words. I know, but it's just it feels natural to have these features in Postgres itself.
Some of them for sure, but I do think some of it's tricky, like the bottomless stuff, for example. Where would it go? Like what?
There is extension already, right?
Yeah, okay.
S3 compatibility is standard. Even Google Cloud GCS, it's also S3 compatible. Yeah. Everyone does it. So I think no. I don't see why not here. I mean, I see it, but it's manageable.
Fair.
The biggest question is business-wise, I guess. So timescale DB
I understand.
License, yeah. I understand business-wise it's not going to happen in nearest future, but it could be so great to have good compression and bottomless in Postgres itself, even if it's extension. I'm okay with extensions. I don't like extensions in general because I like to all people have some features, but in this case it's okay to have extensions.
Mm-hmm. Cool.
Extensions are great sometimes, yeah. Good, okay. Have a good week. I know we have more than 100 suggestions in our doc. We read them. Keep posting. This was one of suggestions, right?
Yeah.
So you chose it. Yeah, good. Thank you for our audience for patience for reaching this point. Okay, see you next time.
Absolutely. Take care. See you next week. Bye.
Bye-bye.